Hello, in this video we're going to cover problem 3 of the ESE 403 final project. And so this problem, we have a company that wants to employ a new intranet system for their company so that they can have productive communication, because it seems like they are really out of sorts as far as their communication goes. The marketing team doesn't know what the sales team is saying. The sales team doesn't have communication with the manufacturing team, and the manufacturing team can't talk to the warehouse team. So new intranet program is going to be installed. This is going to require a new set of servers in order to support the intranet program. And we know that there is a course of action where the intranet program is going to be installed gradually from months 1 to 5. And with varying levels of employees at each milestone being brought onto the server, we want to figure out in what order we should buy the servers in order to support this program. And so we're going to start with a very simple linear program of doing it month by month, where we're solving each month as if it was its own problem, irrespective of the other months. And so in order to do this, we're going to have 5 different LPs, although the first one is quite trivial, so we'll kind of jump right into it. So first, we're going to change the nomenclature a bit. We're going to let X1 through X4 be the different types of servers. And so for the first month model, right, this is the education month. There is no requirement to bring anyone on. And so because of that, but we do have a requirement of spending. And so because of this, we kind of have a pretty simple problem. So we have the minimization, because we're trying to minimize the cost that the company incurs through this intranet installation. We also know that in the first 2 months, we get special deals from servers 3 and 4. Particularly, we get the third server at 10% off for 0.9 of that $10,000 that it costs, and we get server 4 at 25% off, or 0.7 of that $25,000 cost in the first 2 months if we purchase them. And so that is how we arrive at the first optimization linear program. The first objective function is just the cost of the first server times plus the cost of the second server plus the cost of the third server plus the cost of the fourth server, subject to the constraint that we spend less than $9,500 in the first month. Of course, it's a pretty trivial solution. It's going to be 0, because that's how we minimize the total cost. And of course, X1 through 4 have to be greater than 0, and they have to be integers, because we can't install partial servers. So with that out of the way, we can get into the real meat of the problem. So month 2 is when it really starts to matter, or constraints. So we have the same exact objective function with those special savings employed, but we have not only that we need to spend less than $9,500, and again, this is a little bit of a stretch, but we know we can spend less than $9,500 or less in the first 2 months. Knowing that you're not going to spend anything in the first month based on this month by month, I kept the same right-hand side constraint here. More importantly, the constraint of having to support at least 60 people on the server. So this is going to be the number of people that each server supports added together. And again, X1 through 4 should be greater than 0, and they have to be integers. And so this solution is going to give us that we should either buy 2 of server type 1 or 1 of server type 2. It doesn't matter. Both are going to meet our 60 or greater support level for a total cost of $5,000 in the second month. For the third month, we have a similar objective function, but a little different. We lose the special sales deal, so there's no more extra coefficient there. And we also lose, though, the constraint that we must spend less than $9,500. So our only constraint here is that the support of the servers is greater than 200. And so the way to minimize the cost here is pretty obvious. It's just to buy 1 of type 3 at a cost of $10,000. Then we'll move on to problem 4. Again, very similar, just the constraint that we must support at least 30. We should buy 1 of server type 1 for a cost of $2,500. And for 5, we need to support 75 people, so we're going to buy either 1 of server type 2. I'm sorry, she should buy 1 of server type 2, not either. There's only one choice here to minimize the cost. And so the total cost then over 5 months is going to be 0 plus 5,000 plus 10,000 plus 2,500 plus 5,000. That's going to give us $22,500. And so that will be, if we are just looking at it on a month-by-month basis, trying to make sure that we are supporting each month's requirement. Now, again, this does not really think about, and we'll talk about this a bit later, if there's any residual room on the servers from a prior purchase. But before we get into that, I'll show you the linear programming implementation of it. So we'll open up problem 3, and we have 5 different models here. So again, it's just very simple. We can run each of these, and it'll give us our optimal solution that we're expecting for each month. So very simple implementation here, 4 variables, just integers, and that's about it. But much more interestingly is the problem where you are over the entire period. And so for this, you need a variable xij. So it's where I is the number of servers, a number of server type I bought in month J. So X is the number, I is the server type, month is J. And so this is, we're going to be looking over months 1 through 5. And this makes everything a little bit more complicated, but it's really just like adding all of those individual problems together. So we have objective functions, right, where looks like very similar to what we've seen before, but so 2500 x11, so that's type 1, right, month 1. 500,000, or sorry, 5,000 x21, type 2, 1. We have the special discounts built in, and we go all the way through month 5. Now, in terms of the constraints, we first have the spending limit constraint. Here we can properly account for everything in the first 2 months being less than or equal to $9,500. And then we also have the server site requirements, which is here we are enabling ourselves to think about not only if there's residual room in a server purchase, but also it's how the model is going to know if there is need down the road that we can satisfy early on, in particular with respect to taking advantage of those discounts. So for example, in month 2, right, because there is no requirement in month 1, but month 2 means that all of the server size capacity from months 1 and 2 must be greater than or equal to 60. And then we have the same thing for month 3, month 4, month 5, where what we're doing is we're adding to the previous requirement the new requirement, and that becomes our right-hand side of the problem. So the first month we need 60, the second month we need 200, but what really is happening is that we need that in all of the servers bought in the first 3 months, for example, you need to be able to support 260. So it's a step-by-step integrating those increased server requirements, but again, the problem is able to take it all into account. Again, xij are all greater than 0 and are all integers. So the solution here, and this will show the implementation in IBM DOC first, the continuous function, I'll call it, is formulated like this. We do have quite a few variables, but if we run this, we will get a objective function value of just $19,000. So let's take a look at how that works. Well, this model is going to take advantage of the discount on one of those servers. So we should buy one of the type 3 servers for $9,000 in either 1 or 2. It doesn't matter because it'll satisfy everything as far as what we need. And then an additional SGI server, type 3 server in month 3 for $10,000. And so that will cover us all the way through month 5, which is great, and only at a cost of $19,000, which is considerably less than $22,000. So now I want to cover just why those methods are different. Basically already explained it, but it's because it doesn't account for those discount offers. The first problem would never take the discount offer in the first month or the second month, because it just doesn't need to spend that much money for 30 people. And it can also has this sense of being able to look ahead and look back and see if there's residual room or needs forward room. So that's what's really important. Some other costs, though, that aren't really implemented in this formulation, or aren't given in the problem, that really make this formulation not great. There's no idea about there's labor or installation costs, to either wiring or cabling required, or man hours, for example. There's learning costs involved with a new intranet system. How much decrease in productivity will there be and what is the dollar value associated with that decrease in productivity from learning and possibly distractions, that sort of thing. And finally, maintenance and upkeep. Is a new IT person required to help on the system, or what happens if it breaks? That's a great question. And is it upgradable, that sort of thing. And then lastly, just going to cover some other concerns that the teams might have about the upgrade. And certainly, I think it's the training, right? If training everyone in month one, but some people aren't getting it until month 3, 4, and 5, are they even going to remember what they need to do come then? And then what are the ramifications of not remembering? Another problem is, what if data's, not that it's going well now, but what if data is implemented wrong? If there's an extra zero, it could really, really make some huge differences. And in that sense, it's, in some cases, the lack of information might actually supersede having really poor information. And finally, what if the system crashes altogether? If the company is solely reliant on this system, what happens? What's the backup plan and that sort of thing? So those are all some of the concerns that I think the group should have as far as the implementation goes. That is it for problem number 3, a much shorter one this time around. So thanks so much, and I hope that was a great, clear explanation of how to solve this problem. Thank you.